Hello. Today we're going to work on dilations again, and this time we're going to use what we call the ratio method. The ratio method is really just taking whatever the scale factor is and computing what the respective line segment would become. So our objectives are students create scale drawings of polynomial figures by the ratio method, and given a figure and a scale drawing from a ratio method, students can answer questions about the scale factor and the center. And so as you look at this, you've actually been given some steps. So some vocabulary within those steps might be scale drawing, polynomial figure, ratio, scale factor, and center. They create a scale drawing of the figure below using the ratio method about center O. And so highlighting and annotating these things becomes really important, one, so you know what you're doing, but there are some key words that will help you as you go through these dilations. Center is one of them, scale factor is another, because the scale factor gives you the numerical value that you're going to manipulate your line segment. So step one says draw a ray beginning at O through each of the vertex in the figure. And so I've already done that, so you may want to pause just to catch up. And so through O, I drew each of the lines. And then dilate figure or each vertex along the appropriate ray by a scale factor of R equals 1/2. And so as you go through these, what they mean is you put your 0 on the O, and you go up to the D, and you realize that this segment is 9 centimeters long. So the halfway point would be 4.5 or 9/2. And you kind of keep doing that. So you again center everything around O, come to E. E is 7, so OE is 7. And so this is going to be 3.5. You swing it around to C, recenter it on O. You realize O to C is 10, so halfway would be 5. And then you go to B, that's also 10, so 5, and A is 7, so at 3.5 we put another dot. When I get done with all this, I can connect it with a straight edge. And so if you're thinking about where I use this, artists use this all the time for perspective drawings where they're dilating kind of to a point in the horizon. And another thing you want to remember is that whenever R, so these are the context clues, R is greater than 1, you know that you have an enlargement. And when R is between 0 and 1, you know you're going to have a reduction. So within each problem, there are oftentimes context clues that will help you make sure you're doing this right. And now if I've done this correctly, each distance, so from A to B, I see that 3 centimeters here, so it should be 1.5 centimeters over there. And it is. And if I'm going around this, it looks pretty much like a square, but maybe not quite. So 3, and then that's 1.5. C to B is also 3, so this should be 1.5, which it is, and so on. Each segment should be half of the original, the pre-image. And so let's make sure we understand that this is your pre-image. This is your image, just to remind us of that vocabulary. Okay, and if we wanted to, we didn't have to use a ruler. Ruler's pretty quick, but we could also have used compass. And so remember, if you're going to do this compass, each of these would end up being the perpendicular bisector piece. So you'd have to draw each of these arcs. Take your ruler. And notice where this perpendicular bisector intersects the line connecting O and D. We already had our point, okay? And so now you have essentially two methods, two understandings of how to do this. All right, so going to the next problem. I read through this and it says, example number 2, create a scale drawing of the figure below using the ratio method about center O and a scale factor of 3/4. So again, we want to make sure we understand where our center is, because that'll change whether the O is in a different spot. And our scale factor of 3/4, it'll change what the image would look like. Now, how do I get 3/4? If I were to use a compass, we'll talk about that in a second. But for the moment, let's just dilate this 3/4. So step number 1, we're supposed to draw the rays for each point. Now in truth, I don't actually have to go beyond this point, since I know 3/4 gives me a reduction. But I just want to go through the fundamentals of how to do this. You never know, you could be asked to draw a dilation on a grid, a coordinate grid. You could be asked to draw it on a piece of paper. You could be asked to draw it in an art class. Maybe someday you're an architect and you have to understand about scale drawing, or you're a geographer and you're looking at maps. And so understanding scale has many important pieces. Maybe you're a contractor and you're reading a blueprint so that you can build a house properly. Maybe you want to add an addition to your house. So there are each of the rays. This one becomes a little bit more complicated just because of the number of vertices that we have. And then we move forward. So from O to A is 9, just under 9, but I adjust it, and so here's my midpoint there. O to G is approximately 7 point, well, really 7.3. So I'm going to go 3.6 heavy. 3.6, kind of in between 3.6 and 3.7. Gotta readjust my ruler. G to A, or O to F, 7.8. 7.8 divided by 2, 3.8, 3.9. C is 9, so 4.5. On B is 9.6, so 4.8, or 4 8/10. E, again, about 7.3, so 3.6, a little bit heavy. And D, 8.6, so 4.3. Okay, and as I look at some of the dots that I put out there, the A dot looks a little bit off, so I'm just going to double check to make sure I got it in the right spot. Yep. And so now we can connect this. And so each of these were a half, so R equals 1/2 was my scale factor to create that. And what I want to make sure we understand is that we double check our reading, and we notice it's 3/4. And so I did this so that you could see how this could work out. So again, if you have your compass, you can definitely create the midpoints, and then essentially you find the midpoint of your midpoint. And so, like, if I were to do this, what it would do when I gave the ruler to it and looked at the straight edge, right here would be the 3/4 mark. Okay, and that's how you'd use a compass to do this, but we have a ruler in our possession, and we could have just measured. So 9. So if my distance is 9, I'm going 3/4 of that. That's 27 divided by 4. And so 27 divided by 4 is 8 3/4. No, 7. 6 3/4. So I need to make sure I'm at 6 3/4. So 6 3/4. So right there. And you can see that it's right between the 6.7 and 6.8, which would be 6.75 centimeters. Okay, and you keep going around doing this. Obviously 3/4 is much harder to do than 1/2. So you may want to break out a calculator and say 7.3, 3/4 of 7.3. is 5.475. So really, really close to 5.5. Just make it maybe to the other side of 5.5. And then F, 3/4 of 8 is 6. And then C, point C, 3/4 of 9, 675. Look at O to B, 3/4 of 9.2. Is 6.9. Wait a minute. Three-quarters of 9.6. 9.6 times 0.75 equals 7.2. Yeah, that dot didn't look quite right. And so sometimes you definitely have to check your work. If it doesn't look right, because it should have a similar shape, then you might have to readjust what you're doing. So 3/4 is 7.3. It's just under 5.5. And the last, D, 3/4 of 8.6 is 6.45. Okay, and hopefully this sets you up so that you understand how you could use any ratio that they give you to be able to dilate. So you take the ratio, you multiply it, and so then when you're looking at the side lengths, so this is, let's find one maybe that's easier to work with. That's just under 2, so 3/4 of just under 2 should be about 1.5 centimeters. And it is just under 1.5 centimeters. Okay. The last